All right, so let's talk about the exam because you want to know about it, I'm sure. All right, so the scenario is that all except the ERD at the end are all worth 1 point each. You have 4 possible scores for each one. So 0 means you completely didn't give me anything that resembled enough that I should give you any partial credit. 0.5 says you gave me something, but there's something missing, something wrong with what you gave me, right? So clearly we're missing something, so I can't give you full credit. On anything that has a 0.5 associated with it, if something's wrong, I put an X through it. If you're missing something, I have put some word, some phrase about something I was looking for. That is not an indication that that is the only thing, right? I wanted to at least give you one specific thing that I was looking for that I did not find. A 1 with an okay after it means you got lucky, meaning you got close enough, you didn't have it completely right, but I was okay giving you full credit for it. Okay? And then obviously a 1 indicates that you gave me what I was looking for, or in some cases, you guys love to write, so you give me way more than I wanted, but that's okay. Right? Right, so 1 with an okay, a 0.5, or 0. Right. Okay, Mark.
Yes.
What does the note say right under the, where it says exam, midterm exam?
When asked to provide an example, it must be different than examples described in slides or class discussion to receive full credit.
And I believe must is in capital
I
letters.
believe must is in capital letters.
And I believe I stated that when I handed this out.
Maybe? I don't remember. Yes.
Yes.
You must have.
Yes. Okay. Because a lot of people gave me the examples that were not in the class, but there was people that obviously went ahead and did, and I noted that. Right? So again, my view is you being able to memorize something, give me something back out of a slide, does not tell me you understand it. You giving me an example that is different, but still correct, tells me you understand it. Right? So that's why I specifically asked for it that way. Okay? So I appreciate in number 1 that a bunch of you really went and wrote like a whole bunch of stuff associated with this when it's 1 sentence. So what is the difference between data and information? Data is a fact, and information is taking that fact and putting it into meaning, context, right? Something like that. That's all you had to say, right? So I even got one that like filled up that entire thing and then, circled it to the top and filled it. That's all I was looking for. Data is a fact, and information is taking that fact and putting it into context. Okay, so what is a mini world? And Mark, since you're doing such a great job of reading, what is the second part of the question?
How do you know what is in it?
How? How do you, not what is in it, how do you know? Right? So I was looking for what way do you know what's in it? Right? So what I was looking for in this one was the mini world is a part of the organization. Right? So it could be the whole thing, but in general, companies and organizations are so big, you have to pick pieces of it. So therefore, the mini world is what is the piece we are specifically interested in. Right? And once I decide what is that mini world, so what is the BSIM, what describes it completely? The complete ERD, right? So a lot of you said, it's what's in the database. No, the mini world is what you are interested in, and you're going to make the database and the system around it out of that, but it's not necessarily equivalent one-to-one, right? So the mini world is what is the part of the organization you are interested in. How do you find out about it? You conduct interviews, you look at documentation, right? Things like that. And you create the complete ERD, or if one already exists, you're able to look at it, and that's going to have everything that is contained in it. And everything in terms of applications, databases are all equal to, or more typically a subset of that. All right, so what is the difference between a database and a database system? So a database is what? The data, right? Right. So a database is nothing but a set of data, right? That is consisting of the data in our, right? Well, it's part, the metadata is a component of this, right? But the database is just the data itself, right? All of the instances of, right, data. The database system is not only the data, but all of the things around it. So it's the metadata, it's the applications, right? So it's the database management system itself, right? So the components that we have associated with the database system are application, database management system, the database itself, and the metadata, right? So there are 4 specific components associated with that, and the database is the data itself, the database system is the database plus all of the surrounding components that make all of it work. Okay? So Mark, doing a great job. What is the underlined word in number 3?
Discrete?
List.
Oh, sorry. List.
This is why he got the grade he did, and I won't tell you what he got, all right? Right? So, list. So I appreciate where you guys went and described all of it, you know, and your hands are hurting at the end of the night. You did all that extra work, and I appreciate reading it, but didn't have to do that. It was list the 4 components and just describe the differences. All right. All right, so I'm sure Mark was thinking that I had already moved on because he really isn't paying any attention to me. And the number 4
That's discrete. That's the one.
is describe, and describe equal to a list. No, in this one you had to expound on all of the things, right? Okay, so describe the functions of the database management system. And Kendra, what are all of those?
Let's see, I got full credit. Defines the database, creates the database, and allows for manipulation of loaded data, and also allows for the processing and sharing.
And sharing, right? So you didn't have to have those exact words, right? Again, right? That's exactly what the nice slide said, so I appreciate Kendra was able to just blast it all down, right? So if you said, instead of sharing, you said accessing, that's okay. Processing, right? Application, right? So you can substitute words. I'm, again, trying to understand what you are thinking about this, right? So it's a, right, so several people, instead of saying creating, would say loading. Right? That's okay, right? So again, whatever wording you said is, and you, if you want to think about it, it's all about what? From the very beginning of defining it, putting data into it, being able to access and process against it, right? That's what we need to be able to do from a functionality standpoint, okay? Okay. Now, this is typically where I started circling things. So in the description, so in the question, if I couldn't find the answer for your part of that question, you'll see it nicely circled, which of course made it easier for me to grade, and I appreciate you trying to save me some time, right? Okay. But I believe, as Mark was completely ignoring me when I went through and said your examples need to be different, I also said the number one thing I take points off for on an exam is you don't answer all parts of the question. So once again, you have proved that to be a true, valid statement for another exam. So I can't tell you the number of times I nicely circled stuff. All right, so what are the trade-offs? Right? And I do appreciate the people who say the trade-offs are, and then they just leave it blank. Okay. That doesn't help the cause, right? So what are your trade-offs? Okay. Okay. So a database management system compared to a file system is going to have a cost, right? So you have to license it. You also have to have the time to learn it and get the skills associated with it. Right? You have to evaluate and determine which of the database management systems are going to make the most sense for you to use, because there's lots of them. Right? And it also means that you need to make sure that it's scalable. What do we mean by scalable? Right? Having a data in something like a Microsoft Access, and you now change it from being 10,000 records to 10 million records, it's not going to work, and you have to convert it. Right? So you have to understand the scenario around what is your data today and what is it going to be in the future. Right? So again, I'm not looking that you had all of those. What I was looking for is you gave me some of those. So more than one. Okay? All right, so number 5, so what is stored in the metadata? And it's not data. So what you started like telling me about the data that's in it? The schemas, right? So it's the definitions, right? So the definitions, wait, we see that right up on the screen, right? So the schemas or the structures, right? Again, I wasn't concerned about exactly what word you used, right? But you had to describe to me that it was the fact that there's a definition. There's a database that holds the data. I'm only going to know what data it is and what the layout is and what format those are in by going to the schema, right? Because that's the second part of the question. How does the database management system use it, right? So any request that the database management system receives is going to go connect to the metadata to say, here's my request. What am I retrieving? What is it going to look like? What's my access path to get there most effectively? Right? Things like that. Right? So you have to have some way of saying the definition versus the way that you're actually accessing it. All right. So on the next one, I confused all of you. So I feel that I have accomplished what I needed to do in this class. Right. So between Number 6 and number 9, they are the same question as what I was looking for. So the fact that a lot of you tried to answer them completely differently, I appreciate you stepping up and trying to do that. Right? That's what happens when, as I tell you not to do, I make up the exams at the last minute. Right? All right, so what I did was, as long as you got one of those right, you got both of them right. And if you put the same thing in both of them, that's okay, because that's the correct answer for both of them. Okay? So, I apologize. It's not my fault, like I fall on the sword. Okay, so Kendra, what's the answer to that one?
Internal, conceptual, and external.
And since you had to tell me about them and describe them, what would you say would be a great description of those?
Well, for internal, I would say it's the physical design layout of the data in the database. Conceptual could be, or could describe how the data is and how its relationships exist at a high level. And external is describe how the data will be displayed and how the user will interface with it.
Yeah, right? So the way you want to think about it, right? This is very simple. The user outside, right, doesn't have any clue about any of this stuff, right? Especially if you have a GUI interface, right? There's pointing and clicking in, right? And they have an idea of what it's going to be. I know that it's a date. I know that it's a character field, right? They don't know how it's all related with all the keys and all that kind of stuff. They just have in their mind, they have a view of what it looks like. So it's an external view, right? Okay. Again, yes, sir.
Can I get my result?
Can you what?
Result? Yeah, paper.
Maybe. What's it worth to you? You sneak in here? When did you sneak
I
in?
came late.
Oh, yeah, it wasn't my fault. Right? Asking the question twice was my fault, but, okay, and you are, sir?
Just read.
All right, so external is this high-level view from the user of the system. They don't understand the details. They don't care about the details. They just care about the data. What about the conceptual, right? The conceptual is typically an application developer, right? So somebody who's going to know more about it, but they really don't know the setting up of indexes, right? How all the keys are all fitting together. All they want to know is I can go retrieve the data and it's going to give me the answer I want. Right? And then the internal is somebody has to create it. So that is going to do everything that is going to be requested by the system, right? Meet all the requirements, right? So 3 layers, because 3 different views of the exact same thing for different reasons. Okay, so again, 6 and 9, right? We're looking for the same thing. Okay. All right, so I think, again, I will say that it is my fault. Number 7. What's the first word in number 7, Mark?
Describe.
Describe, but I didn't underline it. Right? So clearly that changed what it meant to say list it. Right? So a bunch of people would say that the types of database languages were the data definition language and the data manipulation language. And they didn't describe it because I didn't underline it. Right? So I'm sorry I did not underline it, but I still expected you to describe it. Right? So what is the data definition language? It is the language commands that are describing the definition or the creation of the schemas that ultimately are going to go and land in the metadata. Right? And the data manipulation language is the language that is to manipulate the data in some way. So whether it is just retrieving it, it's adding to the data, it's changing the data, or it's deleting the data. But it's not changing anything about the structure of the data. Okay, so what's the next part there, Mark?
We're on number 8, right?
7.
7, sorry. Who would use each one?
Who would use each one? Right? So who is going to use the definition? That's your administrators, right? So data administrator, database administrator, right? I think here, one way, but somebody who is administering this, right? The people who are managing the creation and monitoring of this data, right? The ones who are going to do performance tuning, things like that, right? Okay, and who is using the manipulation side, right? It's the users that are actually accessing and doing something with the data itself, right? Because they're not changing the structure, they are working with the data. Okay. All right, so I'm apologizing over and over again. Number 8, I shouldn't have given you a hint because most of you just ignored the hint I gave you. Okay? All right, so it says, what is the purpose of a data dictionary? What is included in it? And include non-database data. So what's that mean? I'm expecting you to say something about non-database data in your answer, since I gave you the hint. Okay? So if you didn't have it, can't get full credit. Okay? All right, so what is the purpose of a data dictionary? To give definitions for any term, in quotes, that is within the entire organization. Once you have a definition, it could be where is it used, examples of it, how does it relate to other things in the data dictionary, right? Okay. And so a lot of you said correctly that it's got the database in it, and it's got the attributes. It has the structure. That is all absolutely true. What also does it have in it that is non-database related? What did we say on day 1? And multiple times since then. Every organization has what? Their own language. Words have specific meanings associated with them. You go to any company, you put out a set of words, then they will have, you could find specific words at every organization I can think of that I'm associated with that have a specific meaning only to that organization. Yeah.
Could we consider that implied by saying metadata, because the metadata relates to the mini world you're describing, as well as the data?
The metadata is a catalog. Metadata contains the schema and the structures associated with that. It does not have,
Doesn't have any other outside material, you can't, I guess, attribute it to the outside. Maybe it's a stretch, but I just thought
so this is the perfect example. So Kendra, I should pay you for this question, but I'm not going to, so don't worry about it. Right? Okay. So, right? What Kendra is saying is that her interpretation of what a metadata is has a meaning to her. Metadata has a specific meaning to me, and mine is right. right?
I guess my question wasn't that I have a misinterpretation of it, it's that it could have two different meanings.
Yeah. But what is the meaning that is specific to, in this case, this class,
Fair
right?
enough.
Right? So again, right, you take a given word in a organization and go to a different organization, they can have it can be the exact same word, but it can have a completely separate meaning. Or it can have multiple meanings. Right? So I gave you the example of that I had my job as a database administrator, I had to consolidate meanings of the same term, and we went from above 30 down to 6. But that means I had to get everybody to consent on what that meant and what the values would be and put it into a data dictionary so that if anyone wanted to know what this meant, here's what it was. And I also had to have in there what it used to be. Right? So you're absolutely correct, right? There is 2 versions of this that you could come up with, probably more, if you talk to everybody, right? But we have to settle on what is it that you have in the organization, in this case, a class, that you're responding to. Okay? Does that make sense?
Oh, yeah, totally.
I like when she agrees with me. Okay. Okay. Right. So I gave you the example of what the dictionary looked like, right? So it had the actors, it had the use cases, it had attributes, it had data structures, right? It had all the different things and how it was all related to each other, right? So I was looking for, there's a definition, there is relationships between the different pieces of data that you are recording in here, there's examples of it, right? So again, you did not have to have everything that I just asked you for, or we discussed, right? But you had to have enough in it that I knew you understood what a data dictionary is and why we would want to create one. Okay, so then we said, why do companies typically not create one? Time and cost. And it's not just to create one, but it's to maintain it. Okay? So that's a huge impact. So therefore, what do we do instead? I didn't ask this, but what happens if we don't do it? We actually spend more time because we're not in alignment with what it is. We don't know what it means, and we all make assumptions because we know what it means, right? And then we have to go back and correct things, or it's so big and complex that we don't, and now we have multiple definitions of the exact same thing, so it actually ends up costing us more time. Okay? So I didn't ask that, but now I can. All right? All right, so what is data independence, and describe the types. So, Cooper, we haven't heard from you at all today, so why don't you give us some insights on that one?
Generally, the idea is that you can change different parts or different levels of the schema without disrupting lower parts of the schema. So from a external level, can you change the conceptual level and the physical level?
Right, so we have 2 levels, right? So we have, what are the 2 levels, Cooper?
There's at least external, conceptual, and internal, but the machine cares about what you're, the external and the internal.
Right, but the 2 types. What are the 2 types?
Of independence?
Mm-hmm.
Oh, geez, I wrote 3. So that's a hard one for me.
Then you better ask someone that's sitting next to you on either side,
Well,
and they would probably know.
I think there's program independence and physical independence, right? At least.
right? So logical,
Logical. Yeah.
physical, and logical. Right? Okay, so what Cooper's going after is we have 3 levels, right? So if you think back to the description we had earlier, what do you have at the lowest level? You have the internal layer, and then we have conceptual above that, right? So our first set of independence is I can change one without impacting the other, right? And then you had the conceptual to the kind of external view, right? So can I change one of those without impacting the other, right? So you're looking at sets of 2 and being able to change them independently, right? So that because what happens if they're impacted? People have to make changes, right? And what happens when you have to make changes?
Costs money.
It costs money, right? We had a nice graph that told us how much it's going to actually cost us to do that. Right? So our physical independence is being able to change the physical schema without having to change the logical. Right? Okay? And the logical independence is not having to change the logical if we need to change the external, right? So as you work your way up in the process. Right? Okay. So we typically also don't, right? So this isn't part of the question, right? So I wasn't looking for this, but we also have kind of what Cooper was added as a bonus for me, right, as I read his thing, was program independence, right? So program independence is we want to be able to change the programs, which is kind of external to external, right? So we have different layers of that. So he gave me a bonus, so thank you, Cooper. Appreciate that. All right, compare and contrast the use of centralized and decentralized databases. So Mark, what does compare and contrast mean?
Means to describe them separately and then describe how they're different.
Right? So how are they the same and how are they different? Right? So if you tell me a centralized system puts everything together in one central place, am I going to give you full credit if that's your full answer? No. Right? Okay. If your answer is to decentralize, you are not putting it all in the same place. No. Right? So you had to give me something that compared how they are the same and how they are different, even though one says we are centralizing things and putting it all in one place, and the other one is we are decentralizing it, so we are spreading it across multiple. So some people went with it's all on one server or it's on multiple servers. No, that's not it. It is physical locations that we are thinking of. Right? So how are they the same? Right? So if I have a centralized versus decentralized, I still have one and only one logical set of data. I have one database. Okay? The data is broken up and spread in a decentralized one, but I can still look across all of it to get the same result from a external view. So why would I decentralize? Because I have so much data and I want it localized to where it's being used so that we can get to it and process it faster. Right? So if I have 10 million records and I break it up into 10 locations of 1 million each, the database management system is going to take less time to process against 1 million than it takes to go against 10, right? But what is spreading it out also doing? It's causing me to do more work on the, for example, security side, because now it's in 10 actual locations, right? So whether you gave me something about its physical locations, management of that from a skill set, right? Management from it from a resource perspective of people to manage multiple locations, multiple hardware, right? Things like that, compared to it's all centralized and I can gain efficiencies that I wasn't looking for necessarily a particular one of those, but give me enough to tell me, you know, that there are trade-offs of doing something of centralized versus decentralized. Right? All right, the client-server 3-tiered architecture. Okay, so Mark, what are the 3 levels?
Sorry.
See, you can tell that he studied for the exam and is not retaining it.
I have retained it, just switching between. There's the client level, there's the DBMS server, and then the application server operates as a.
Right, so what do you have at the top? You have the client, right? So you have to have something that faces off to the user. Right? In between, you have something that is going to do the process. And then to do the process, we have to go get the data and act on that data, right? Which is going to be where the database server is, right? So why do we want to separate those? So again, I wasn't specifically asking for this, but besides, right? So what do I want at the client level? I only want the minimum, right? So we have the concept of, you may have heard of the term thin client and fat client. What's that mean? What happens if it's a thin client? You typically are running something like a web page, right? So you are doing only the minimal things you have to do at the client layer. Because what do you want to do? I want to have the smallest package there because I want everybody else to use one process at the processing level, so the application level, right? Because what happens if I have to distribute something as a fat client where all of the processing and the business logic and stuff is at the client level? I have to distribute it to 3,000 PCs in the company. Rather than, here, use this new link. Right? So it's to do things that require a lot of processing at the client level makes 0 sense. So we want to keep that as thin as possible, go against it, have the results I want, right? But I have to do minimal processing because I don't want to tie up the traffic and the processing of the processing if my data is invalid, right? So the minimal processing you do on the client layer is, right, you edit the input data fields to ensure they're valid, right? Because if they're not, I don't even call the application layer. And I need to separate out the data layer versus the application layer versus the data, because I want the database management system to manage things and request and use that only in one place. Okay. All right. Add what is missing to this diagram. I appreciate the people who said there is nothing to change. I never thought of putting a question like that on the exam. But there was things to change. Okay? And there was actually 5 things to add to this. Okay, so we have the mini world. And what describes the mini world if you go back to question number 2? The complete ERD, right? So I should have the mini world, so I need to define what that is, and then we should describe what the complete ERD is associated with that, so that should be in place. Once I have that, that's describing the entire mini world in terms of its data, I then have a problem to solve. So after the complete ERD comes what is the specific problem I'm going to solve. Then we fall into the requirements, and what of the requirements is missing? The non-functional requirements. And what is non-functional requirements? That's not functionality, it is the constraints. How fast does it have to work? What point in time of the day does it have to run? What is the window of time it has to run in? When are the updates going to be available? Right? Things like that. Right? So it's got nothing to do with the functionality you're trying to do, but it's constraints you have to take into account. Right? So I have had plenty of databases that worked from a functionality perspective that we had to change the structure of, typically because it was not fast enough. So it didn't change the end result, it changed how the database management system functioned. And after you build it down there in the application programs, what's left to do? Cooper, you had part of it. Validate, so we have to test it. And then once we test it, we have to deploy it. Right? Because testing is saying, and now I'm done. Well, that's really great, but somebody has to deploy it. And we could potentially add another one that we talked about onto that, which is monitor it after we deploy it. So the key ones I was looking for out of this, though, were the complete ERD, problem statement, non-functional requirements. Those were the 3 key ones that I was looking for. Okay. All right, so number 14, describe the types of ERDs. So how many types do we have? 2. We have complete and build. What does complete represent? Everything that is possible, right? So that's why it describes the mini world in its entirety, because it is describing everything. There should be no piece of data that is missing out of your mini world compared to the complete ERD. So therefore, when should the complete ERD be created? It's outside of any project. You don't have any problem you're solving because it is a data model. And the data model is representing your entire mini world. Okay. So it's before you do anything else. What about the build ERD? That is coming after you have the requirements, right? So that's that logical design kind of stuff that you're doing, right? Okay, so I can't come up with my build ERD unless I know what all of my requirements are, and it includes the data requirements. It takes into account the functional requirements and also any of the non-functional, right? So the combination of all of those literally will have some impact on what so what's the main one? Data, right? So what are my data requirements to do the work I'm attempting to do, right? So I can't do the build ERD until the requirements are complete. Okay. Okay. So that's the one that a lot of people skipped, was when are they created? So if you have when is or when circled, right, means you didn't have that in there. All right, so what is a unary or recursive relationship? It is back to itself, right? So again, I had a lot of people that didn't, when they drew and gave me the example, they didn't link it back to itself, and it's like, well, that's what you just told me it was. Now you give me an example where it's not, so now I'm kind of really confused because your words are saying you know what it means, but in the example, you're describing something completely different. Okay? So, depending on your example, you should have one entity. We should loop back with a relationship back to itself for some reason, right? So back in our example up here, right, so a lot of you use the employee supervisor thing. Well, guess what? We talked about that so many times. The answer is no, right? So, all right. Number 16. How is inheritance identified in an ERD? Give an example. So Mark, what's give an example mean? Probably give an example of something.
Give an example that is not one that we give in class.
Yeah, I believe on yours I put like example in class or
I did
something.
okay. We're on 16.
Yeah.
I did okay on that one.
Oh, did you?
Yeah, on that one.
It was the one before that then.
And the ones after.
Yeah, the one before, the ones after. Right. Okay, so inheritance in an ERD is a type of relationship. Right. So a lot of you said superclass, subclass kind of things, right? Okay, that is kind of right, but kind of wrong. So even though I kind of let that one go depending on how you worded it, right? Okay, because an ERD is not talking about classes. An entity relationship diagram is talking about entities. And yes, an entity is a type of class, but it's not the only one. And I can have superclasses and subclasses of the other types that are not entities. So we have three types of classes that exist. We have boundary classes, which are interface classes. We have control classes that are processes. And we have entity classes that are literally the entities in the ERD. Okay? So to tell me is just a combination of superclasses and subclasses. No, because I can find examples where that is not going to be part of the ERD, but it is a superclass, subclass scenario. Right? So again, I just want you to know, if you wrote that and you wrote it correctly saying superclasses, subclasses, I let you have that, but technically that is still wrong. Okay? All right? So, is the relationship. It means that, and these were all kind of tied together, right, in the next ones, right? So what is the relationship, right? It is overlapping. It's that partial stuff that we have in the next example, right? So I tried to put these in order that we talked about them, and if you knew the answer to one, it could help you in the next one, and if you knew the next one, you could go back and check it. Wait, that's traceability stuff. You guys should do that on the final, right? A lot of these tie together, and I've given you some of the hints of how to answer them. Right? All right, so example, right? So again, I had, and they, right, we read it up and down, right? So if we are going down, we are specializing. If we are going up, we are generalizing, right? Right? So I can have a vehicle that's made up of a car, boat, train, right? Something like that, right? Why do we create something at a lower level? Because there's additional data and functionality that is not common across all of them. Okay, so how's it identified? It's is a type of relationship. Give an example. So you can give me any example you wanted where you are literally breaking something up into categories. And then reading up and down, generalization and specialization. All right. Okay, so 17 mark, we got describe underlined. Right. Okay, and I gave you the hint of the letters, so it's interesting when people did not know what they were, what the guesses were. Okay. Right, so is disjoint total, disjoint partial, overlapping total, and overlapping partial. And again, Mark, what's describe mean?
Elaborate.
Elaborate. So listing those four things did not get you full credit. Okay. Okay. So what does disjoint mean? Separate. Right. What's total mean? You know them all. What's partial mean? I only know some of them. Right? So, disjoint is a total. I've identified all the pieces, and you are allowed to be in how many? One. Right? And what if it's partial? You may be in one, or you may be in none. Right? Okay, so what's overlapping total? I have all of them, but you can be in one or more. And what if it's overlapping partial? I can be in 0, 1, or more. Okay. Okay. And Mark, what does give an example of a 1 mean? How many examples do I want? 1. So there was like at least 7 or 8 people that decided to give me an example for each one of them. So again, I appreciate you taking all the extra time to give me things I'm not looking for. Okay. Okay, what is a union? So let's just think back to your math days. What does a union mean? I am taking 2 sets and making them into 1. That's all you're doing. Right? So a lot of you kind of flipped it around and said, I have this thing at the top and I'm breaking it up into things at the bottom. That's not really what we're looking at, right? We are looking at, you have at the top, you have multiple things that you then can combine together into one. Not, I'm taking one and I'm breaking it up into multiple. So I didn't necessarily take off for that, but I really should have, right? So, what do you have as an example? Right, so I always think of Mark when this, right? So I have, he's a dad, there's a mom, and they become parents. Right? He's always talking about it. I can't come to school today, my kid's got an earache. He was up all night, so I got no sleep. Right? Right? So. Right. So union is I have 2 or more things that I add that if I look across all of those, it will then create another instance or another relation, but it's a combination relations of all of those aspects together. Okay, so again, example. And again, I was looking for, gee, we have a vehicle that is owned by a car or a bank or whatever it is. No, that's when I was on the slide. So, right, Mark?
Sometimes you gotta touch the stove to learn.
Yeah. Hate when that happens. Right? All right, so number 19 was so nice to look at. You probably have a whole bunch of green all over yours, right? All right, so on this one, right, there was lots of interpretations of what this was, okay? And the point I was trying to get at with this one was that we have one thing, but it ends up having multiple meanings. Right? So, when I look at field element, right? So that could be a data field, it can be an attribute. Right? You could, but some of you did, stretch the imagination, then said that that's part of a record, so I'm going to link it to a record. Thought that was a stretch, but okay. Okay, and we have a relation is a table, right? So that was the common name for it, but it could also be associated with some people will match it up to a domain, because what's the relation give you? A domain of values. So this gets back to kind of Kendra's thing is, I can interpret this all kind of different ways, and so, okay, so a row matches up to the tuple or a record, right? The schema can relate to any of these practically, right? Because the schema is going to define the table, the schema is going to define what a row is going to look like, it's going to define what an attribute is, right? So it literally can cover everything, right? Okay. Okay, so the key ones I was kind of looking for was all valid values had to be only one and only one thing, which was a domain. Excellent. Right? And what about a database? Match up to a table or a set of tables, right? So there are specific ones of these that I was concentrated more on to give you credit associated with this, but again, the point is if you lay this all out, there should be a whole bunch of things that you should be able to match most of these things up to. Okay, so number 20, why is multiple inheritance rarely seen? Pain in the neck, right? It's complex, it's hard to understand, right? It's hard to implement, right? It's hard to ensure the integrity of the results. But most people just put it's a pain in the neck scenario, right? Okay. Now, I did have multiple people that just said multiple inheritance is rarely seen. Okay, yep. Right? I'm not falling for that. You repeat what I put into the question and I give you credit for it. No, that doesn't work that way. Yeah. Okay, what is redundant tables / data? And what is its impact? So redundant data means you have these same data or these same tables exist more than once. Right? So what's the impact? So a lot of you said it's additional storage. Yeah. Storage is cheap. Right? What is the real impact? Update complexity, because since I have redundant data, the data needs to be updated at the exact same time, otherwise it is not going to work correctly. I can get wrong answers. So a number of people said, I can get false answers. That is a false statement. Why? I can build it so I can handle all that complexity and it's going to work and I have no false answers, but it's going to be really hard to do that. Right? So having redundant data doesn't automatically mean you're going to get false answers. It increases the likelihood you're going to get it. So if you had that type of answer, you had to give me a little bit more than it gives me the false answer. Okay. Okay. What is the definition of domain? The list of all possible valid values. Does it relate to a relation? Yes, it does, because that's where the domain of valid values resides. That's all I was looking for, like 2 sentences. So again, a lot of people gave me nice long dissertations on that. Right? All right. Describe the following keys. So what's a primary key? Uniquely identifies an instance in a relation. Okay. What is a secondary key?
Unique and used for search.
It does not have to be unique. Okay. So a secondary key is something that you are using to search or query the database. I could be looking for a group of things. Right? So I want to get everyone who lives in the city of Dearborn. That's a student here at the university. Well, I'm not going to get one unique instance. I'm going to get lots of people. And that's a secondary key because I'm using it to search. Right? So if you told me that it has to absolutely be unique, the answer is does not have to be. It can also be null. Right? It is a field you are using to search on. Okay, composite. The composite key is what? Where I have a key that's made up of multiple attributes. If you said multiple keys, you are wrong. It does not have to have quote unquote keys as part of it. What you are creating is something that makes everything unique. So it doesn't have to be keys anywhere else. It just has to be a unique thing at the end. Right? And it can be a primary key, it can be a secondary key. Right? Okay. Okay, what's a foreign key? It's checking the value in the, because it's a primary key in a different table. Okay. Okay. And what's a candidate key? This is one where it makes it unique, and you are then going to decide which of the candidate keys is going to be your primary key. Okay, so what is the criteria used in selecting a primary key? Right, so if you tell me it's unique, that it's not null, you gave me the wrong answer. Right, that is true that those are characteristics of primary keys, but I am selecting a primary key out of a set of candidate keys. So, what out of the candidate keys is going to drive me to select a instance of that as the primary key? So, if I can, I want to get to a non-composite key. So if I can get a single value, that's advantageous. What's another one? Business understanding, right? So the users are going to know what the data means and how I can do it. Okay? So as an example, we have lots of tables that have been created over time that we used a system-generated key to uniquely create the instance. But if you ask the user what it is or what value they should put in, what do they need to search for, the answer is they're clueless, because it's some generic number or string that is generated by the system and they can't tie anything together. So in that case, it is potentially better to have a composite primary key of things that the users understand and are going to be able to work with more easily. Okay, so size certainly impacts it, but sometimes we go against that one. So I was looking for something other than it's not null and it makes it unique, because that's what the definition already is. So, okay. Right. So again, I'm trying to tie these together in kind of sequence, right? So what is the referential integrity and how does the database management system enforce it? So referential integrity is ensuring that you are selecting something out of the domain of valid values, and if you already knew what a foreign key was, you just have to put the database management system is enforcing this by using a foreign key. Right. So again, people gave me lots more than they had to on that. All right, so number 25 is what is the unit of work? Okay. So we talked about this at least 3 times that I can remember, and potentially more. And what was that? It was the all or nothing scenario, right? So we walked through the ATM example a couple of times, right? If you go in, you try to get money out, it only does part of it after subtracting money out of your account, and it can't give you the money, you want the money put back in, right? It has to do all of the transaction or none of it. You can't be stuck partway through. So the unit of work is how much it takes, right? So a number of people were describing, even though we haven't talked about it in class, the concept of a commit, right? So a commit, which we'll see later on when we talk about SQL, is you are committing changes to the database, right? The commit is the end of a unit of work. Because what happens if you don't do the commit? It never applies all the things that you have done up to that point. So it undoes them, right? So that process that a number of you described was exactly what this was. Right? All right, so number 26, okay? So this one was worth a total of 4. Okay? Right? Now, this was big. A lot of thought in this, right? So I wasn't looking for this to be perfect, right? But you also had to do all the pieces what I was looking for, right? So how many ERDs did you have to create out of this? You had to give me 2, right? So you had to create a complete, you had to create a build. You had to give me the entities. You had to give me something that described attributes. You had to give me relationships, right? And again, you didn't have to have every single one of them, but you had to have the majority of them, right? So probably the number one thing that I probably did not write on all of yours, but a huge chunk of you did not put on your ERDs was cardinality. So 1-to-1, 1-to-many, many-to-many, right? A lot of you just put, yeah, there's this relationship there, that's nice, but part of what I was looking for is if you're going to draw an ERD, you need to give me cardinality. Okay? So the second thing that was probably the biggest hurdle in this was you gave me things like the system, the company, right, as an entity. Is that right or wrong? I'm talking about it, so it's probably wrong because that is what you are modeling, right? So you can't put in an entity of what you are modeling and have all the rest of the stuff model it, right? That doesn't make any sense, right? So, right, the fact that we have, right, the company has employees, well, that's true, but that's what you are modeling the overall company. Okay, so in this we, right, start looking at some of the things, and right, so we had subsidiary, we had the company, we had a chain, right, we had all these different references to this big thing at the top, which you are ultimately modeling. Okay, so the number one entity that was left out, so we talked about the one that was most put in that didn't need to be there. The one that was left out was, what do they like to do at Bits and Bytes? So thanks, Kendra, for managing that. Okay. What's your customer look at? The catalog. So, should you have a catalog entity? Should you have a customer, since they happen to be here looking at it? Right? So, again, just in reading through this, you pick out the things. I'm going to need a catalog that's related to products, which is going to be viewed by the customer. Okay. 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 Now we have in the first line, it consists of locations and districts. So you need entries for both districts and locations, right? So I don't know where kind of districts just kind of fell away unless you only drew me one and came up with some assumption that it didn't exist. Okay, okay. And did we really care much about the has unique codes and identified by a unique location number? You know, those are just attributes. You don't care what it looks like, right? You're just passing them out there, right? Okay, okay. So we had in the next. So we currently have catalog, customer, locations, district, and we have in the next paragraph, we have employees. Right? Okay. And what about part-time versus full-time? That can be an attribute, right? Okay. Okay, we have an employee number, right? Okay. But we already know that are employees related to district in any way? Yes. Are they related to a location in any way? Yes. Depending on your assumption, they need to be related to a customer or a product. Okay. 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 Okay, location manager, district managers, and what's that mean? Off of employees, I should see some relationship back, right? So, okay. Okay, location reports the number and type of products, so that's got to be obviously in the build, right? So again, I was just looking for you, do you have all the entities? Do you have attributes about those? Did you put them in the, so we have the relationships, and do you have the cardinality? And ultimately, did you give me a complete, and ultimately a build. Okay. So again, I wasn't expecting it to be completely perfect to get a 4, but you had to have something on all of those pieces. And like I said, since a bunch of people decided that cardinality wasn't important, or they didn't have all the entities, right, then obviously you got something off for them. All right? So that's what I was looking for. Right? So again, my comments on this are, in general, you overthought it. So I had a lot of people that would write stuff down and then they erase it. So I have several people that I circled because I could see where the indent from where they wrote and then erased and put, yes, you needed that. Right? So again, overthinking it. It's like, so again, I am looking more for, if you want to put bullet points, you want to give me a sentence or two, right? I'm not looking for these big dissertations, right? Stick to the facts, right? So again, go back to the first one, right? Data is a fact, information is putting it in context. You're done. Move on to the next one, right? Go back and review all of the question. Make sure you've answered all of the pieces, right? So I would say probably 90% of you have something circled where you did not answer all the pieces, right? And I know you guys all understand this, right? So again, I'm not looking for you to memorize things. I just want you to tell me in your own words what they are. All right? Any questions from you?
How many points total?
30.
When are you gonna upload the grades on campus for the exam and for the first homework?
So I don't put the wonderful grades for this out there till after we go over it because all of you panic, right? So they will be out there for the exam probably tomorrow. So I still have to enter them, which is why I need them back, because otherwise you get 0.
Okay.
But if you want to take 0, that's okay. Now, interestingly enough, I also have a dilemma. I have 2 exams that have no names on them.
What are the scores?
Your name was already added in yours, so.
That was stupid.
So I'm trying to figure out what should I flip a coin, just have them randomly pick one. Okay, so now I will. So I need these back if you want them entered. Okay. All right. So any other questions? And yeah.
There is a totally error.
That's fine, just when you hand that back to me, you let me know. And it's, I gave you too many points? Oh. No, I did appreciate, I did have somebody in my other class come up and tell me that my addition was wrong and I gave them too many points, so very honest of them. So, yes?
So the 26th question is for 4 marks or 5?
4.
So the total will be 29, right? Yeah. 25 questions for single marks, 1, and 26 questions.
Look at,
for-
I'm not, my math degree is such a long time ago, okay?
No, I was just asking.
That's why I have to do this, so I have to add 1 to everybody, because then we'll match. So how's that?
Yeah.
Is that okay?
Yeah,
All
that's
right. All right, so anything else? So, bad questions, bad math skills, so gives us a good day. But I'm still alive, so it's okay. All right, so what is due tonight? The status update from your team, right? So I am in the process of putting out there the teams and the project site, right? Because I thought that was more important to get this back to you than do that. Okay, so a lot of the teams have already emailed me their update, which is great. Right? So if you have not, your team needs to send that to me. But I will also want that same one as the starting point, so upload it before next week. Right, so this is week 1. Okay.
What, just, any specifics that you want in there, so just kind of where we're at, what?
Okay, so the status update is kind of what is the overall status? So like one sentence. It's going great. It's fantastic. This is the best team ever. Right? Whatever it, right? So just 1 to 2 sentences. Here's overall where we're at. Okay. 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 Then you are giving me the scenario of what you have accomplished and what is your plan for the next week. So, what did you accomplish in the last week? What are your plans for next week? So, right, so a lot of teams were giving me, for example, we met, we decided on technology, we've evaluated everybody's skills, this is how we're dividing up the work. We are in a, right, and then, right, for what's coming up, we are acquiring some licenses, right, of the software that we want to use. The people that don't know about this are going to play around with it to get some training. We're setting up the timeline to get the deliverables set up, right? So, what did you accomplish? What are you planning to accomplish? And then the final thing is, what, if any, issues that you are addressing as a team? So that's it, right? So again, so today you are sending me an email. Next week you are creating a document that's got the ones that you were in the email today plus next week's. Okay. All right. So Jay is an expert at this. So if you have any questions at all, feel free to ask him about this one. Okay. All right. So Jay's a big fan of this. Right, Jay? Right?
Yep.
Yeah? All right. So you are going to give me 2 evaluations this semester on your team. Okay? And the scenario is you are describing and giving an evaluation of your team members. You're giving me a evaluation of yourself, and you're giving me an evaluation of the entire team as a whole. Okay? So, you're giving me one at on basically December 1st, so kind of the end of the month, right? And then after your project is turned in. So one kind of, okay, so Mark, we're talking about evaluations? Okay, okay. So December 1st, you're turning it in, and then at the end after you guys do your demo. Okay. Now, the way that this works is, as we said, right, it's my expectation and should be your expectation that you and everyone else on your team is going to be doing the same amount of work. That does not mean the same amount of hours. Hours does not equate to work. Right? You are assigning, the team lead is responsible for assigning the work It should be the same amount of work, and if you get it done faster, great. You can potentially take on additional stuff, but if it takes you longer, right? Right, because right, everybody has to get a sense, because a lot of you have not worked together before, right? So the work needs to be assigned based on what you believe it's going to take, and it should be equal. And if somebody is not doing their share, I'm not part of your team. I don't know that they are not doing their share and somebody else has to do extra to try and make up for it, anything like that. This is my way of knowing that. Okay? Right. So, for all of the work that you are doing, there is going to be only one version of it uploaded. Right? So there's only one status report. There's only going to be one set of documents, right? So those are all going to be going up as into the overall project folder in terms of what you're turning in. Okay. For all the evaluations, you are uploading them all individually. So you're not doing it as a team or anything like that, right? There is nobody going to come back and say, oh, well, I saw what you did, right? What you upload, I'm the only one that sees it. If somebody wants to know why they were impacted by it, I summarize everything that is told to me across the entire team, and I come back and say, this is what I got from your team, including you. Okay? So I never show this to anyone. Okay? Right? So you are going to have, besides your turn-in of the weekly status report, your turn-in of documents. So again, you are deciding the order of things and how far you need to be and stuff, but you are giving me a set of documents for whatever it is you want on December 1st. Okay? So that's not something that is going to specifically be graded. I just want you to see where you're at, what you are working on, right? Okay, yes?
Just evaluations are due December 1st.
No, I want whatever you have accomplished up to that point.
Oh, okay.
Right.
The due date is still present before the 18th, correct?
Yes.
Okay. just wanna
No,
make
I
sure
might
I
switch that
understand.
around. I am thinking about the idea of having the exam on the last day of class, and then you do presentations on the 18th. And that way you get the exam out of the way, you don't have to worry about that, right? And you're not trying to juggle both of them, stuff like that.
Yeah, I just want to make sure
Yeah.
that I absolutely understand the due date.
Yeah, so, again, what I have found, if I don't have people turn in stuff partway through, people blow it off, and then, yeah, oh, I don't have enough time, because they're trying to cram everything in the last week, and that never works. Okay? So, okay, so you are turning in whatever you have done, because I want to see that you are accomplishing things. So it's not for a grade as such, but see where we're at. Okay. Okay. But your evaluation is specifically due, Cooper.
Yes, on December 1st. Gotcha. Thank you.
Okay. All right. So the way that this works, right? Okay, is okay. Now this is a tough one. Okay, you are going to order this all by alphabetical order, by last name. I know it's tough, right? But I think you guys can do that. Okay. Okay. So even though I write it there, people don't do that. And guess what? I take off for that, because if you can't follow these simple directions, we got a bigger problem. Okay. All right. So, okay. And I'm going to switch this because I just pulled one up, right? You're going to assign a letter grade, so A plus to, no pluses or minuses on E's, sorry. All right. Okay. So you're going to assign, give everybody's name, you're going to assign a letter grade, including plus or minus, and then you're going to gives me, if you look over here, we have task and behavior. So task is about what was supposed to be done, and behavior is how are they doing on it. So again, you are evaluating everyone on your team, including yourself. Okay? So here's my take on it. If you are part of a team and you have no idea what the other people on your team are doing, then you are probably not a very good team member. Simple as that. Right? All right, so right, the task is the what and the behavior is the how. Right? So again, you are going to assign the letter grade associated with this based on how well people are accomplishing their tasks and how they are going about doing that. Okay. 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 So it's important for me to understand what you know and how you go about this in the description that you put into the task and the behavior. So if you look at the example here, right, we had, so this is for a different class, that's why it's got some other stuff on here, right? But you'll get the same kind of thing, right? Completed part 1 and 2 of the software project management plan, helped develop estimates, research function points, was assigned part 6 of the software project management plan, but did not complete it, right? So again, life happens, right? So you don't have to have everything perfect for somebody to get an A, right? But if they don't do a whole bunch of stuff, they shouldn't get an A, they should get a B or a C or a D or an E, right? Right? You have to decide what it is, okay? Okay. Putting something in there that successfully completed everything. That's telling me you don't have a clue what they did. Okay. Or we all did an even distribution of work. No. Okay, so kind of in the behavior. So good is attended and participated to project discussion in all but one meeting, good communication with others, task delivered with quality, but always at the last minute. Okay. Complete test with quality except for part 2, right? So again, right? Okay. Okay. Bad instances, right? Late on some stuff. Okay behaviors. Okay. Okay. Things I don't want to see on there is we had a team meeting and they texted on their phone the entire meeting. No, that's not like really good behavior, right? You're here to do a job. You have a limited time frame. You all need to step up and be part of the team, right? So, letter grade by name, including yourself. Give me task and behavior. So, you should all be starting off with A's if you do everything that you have been asked to the best of your abilities, right? And again, if you are shifting things, that's okay, right? As I said, you have other classes, you have work, you have other things to do, family things to do, right? So stuff happens, right? So again, at the end, I'm looking for the fact that you believe that everyone on your team has done their fair share, and if they haven't, you have told me that why they should not be given a fair amount. Simple as that. Okay? Okay? So you order that, and then you again do the same thing at the end for your team. How well do you think your team did overall? So as a team, we did this. Here's what we accomplished. Here's how we accomplished it. Right? So again, that's the idea. Okay? So Jay, what was your thought on this since you had to do it? Matter of fact, it was, I think, might have been even this one. Super fun. Okay. Okay. But Jay was able to, right, again, do all of the descriptions in there, right?
Yep.
Okay. Okay? And poor Jay, he had to suffer through one of the hours of fun on that one. Right? So I will have the template version for you guys to use out there for this particular instance. Okay? Right. So any questions on that? So you are turning in 2, and I will again say this, right? Your expectation, my expectation is you are doing the same amount of work. It can be at different points in time. So if somebody's putting together the presentation and stuff, that's a set amount of work, then somebody else is doing the equivalent on something else, right? So it's not everybody has to participate in everything, but you need to distribute the work evenly. Okay? Again, I'm not there to see it, so this is your way to tell me. The thing I hated most about school and work was doing a whole bunch of extra stuff because people didn't step up and do what they were supposed to do. And we all got the same grades, and I hated that. We put in all this extra time, and they get the same grade because they didn't do it. I don't think that's very fair. Right? But this is my way to know that. Okay. And it's always sometimes very interesting reading for us. I have several of them wonderfully posted on my wall of my cubicle that are my favorites. Like the one that starts off, "This project was the realization of my worst nightmare." Ouch. 2 of the team members are the worst boat anchors I've ever had to work with in my entire life. This is the best team ever, and we are going to go on and do all of our projects together as a team because we are going to arrange for that to work. So, again, right, I can't tell you how much this impacts your grade. If you're not doing your share, you don't deserve grade. That everybody else does. Simple as that. All right? So, any questions? Yes,
Would you like these back?
before you leave.
But not yet.
Why don't you pass them all to the side, because Cooper's getting antsy. He wants to be able to run out of here and get home right away because he has such a long drive. Yes?
If we have questions, can we keep them for now and talk to you after class?
Yes.
Okay.
It's as if,
Yeah, I was like, what, you know, maybe, okay. No, I understand.
you can ask me after. Okay? You? Hey, I'm not sitting here till midnight talking to you guys. Jeez. We'll take whatever it takes to do that, but you guys gotta get in line. All right, so, last time we were talking about SQL, right, and what type of statement is a create?
Data definition.
Data definition, right, because we are creating a table in our wonderful database management system, but what is it called outside of the database management system? From our matching? A relation. Right? Okay, and what do we know about this table? We have our attributes, we have the data type, and what's the last column that has not null in it? Constraints. Right? And then down at the bottom we have the fact that we have a primary key listed, right? And now what is unique over here? What is that? What would that be called? unique DNAME. That's also a constraint, right? You are forcing it, right? So it's not a primary key, but it has to be a unique value. So what key would that be then? You guys just took the exam, we just talked about it, it shouldn't be this hard.
It's maybe a candidate key.
It's what?
Candidate
It's a candidate key, right? We just didn't choose it because, right, the department number made more sense to keep track of than making sure that the name, because the likelihood that the department number is going to change is less likely than we change the name of the department. Okay? Okay? And what do we need to specify when we look at the foreign key scenario here? We have the data attribute, but we also have to say what it's referencing in the other table. Okay. So manager SSN is referencing the employee SSN. So what is this going to do? This is doing that referential integrity. Doing what? If I'm going to insert something into the department table, if I'm going to update a record that's in it, and I have a data item in the manager SSN field that says, before you complete that action, you need to go and perform the lookup. And what happens if it finds it? You're able to complete the update. What happens if it isn't there? It's not going to perform the action, right? Because I have a error in my referential integrity. Okay. All right, so what can you tell me about the works on? So we have two foreign keys there. What would cause us to have two foreign keys? So what kind of key is that? Composite, because it's made up of more than one. Right? So it's made up of two. Right? Okay. And what do we know about works on? What kind of table is this? It's a relationship of a many to many scenario, right? And right, what is ours? That is the attribute that is off of the relationship.
So in SQL, when you're creating a relationship, is there anything in particular that says it's a relationship other than it's just create a table, and the way you do that in SQL is how you know that it's a relationship, basically? It has a key from both.
Well, okay, so if we look at works on, right, what is the primary key? How many components? Two.
Employee SSN.
And both of those are primary keys in a different relation. Right? So that's telling me that I have a employee entity, right? I also have a project entity, right? Because if I look at employee, so where's the employee is back here, right? So we had SSN, right? And we had project, right? And project's up above, right? So those are both the only primary keys of those two things. So that means a relationship is the combination of the primary keys together.
Right.
Right? So, going by that definition, I know that works on is the relationship between those two things. Right? Okay. Now, what do you know about the dependent down there? It's got a foreign key, which means what? It's a relationship, right? Foreign key automatically tells you there's a relationship. Okay. Okay. Now, in this case, we have only one foreign key, not two, like we did with works on. So, what do I know about that one? There's a relationship between employee and dependent. And what's the relationship cardinality? One employee can have many dependents because the foreign key is on the many side. Right? Okay. Okay. And what do you know about a one-to-one relationship? It can be on either one. Right? So as a student, you have an account, so I can have an account foreign key, right? Or on the account, I could have a student foreign key. Okay? So when I only have one, I have to determine whether it's a one-to-one or one-to-many. But what's going to describe that? Just logically thinking about it, right? Okay, so in general, you can look at the schema layouts that you have here, right, in your DDL, and, right, so if I gave you this page, right, so list all the things on this slide and the last slide, and said, okay, draw me what the build ERD looks like, you should be able to do that.
And so in that case, you would have employee and dependent, and there's an implied has relationship, but in the DDL, you might not actually need to create that.
Wait, what do you mean?
So let's say if you were starting with like
So I have employee, and I have,
starting the ERD.
Yep.
You would have employee, has, dependent,
Mhm.
something like that. In this case, you wouldn't necessarily have to have a has relationship table.
No, you don't have a separate table, but the has is, the creating of the has is putting the foreign key on here, right? So again, the way you want to think about it is if you have a many-to-many, you literally have to create an entirely independent table of values. Right? That's the only way you can do it. You can't put the keys on one versus the other easily enough, right? Because again, as we saw, right, is on the employee, I could put a whole set of dependent foreign keys, right? But how many do you put? 2, 5, 10, what's the max, right? Okay, whatever you pick is going to be wrong. Right? So, to remedy that, you always take the rule would be, is take whatever your key is on the one side and put it on the many, because then you know there's one and only one that you are going to tie it back to. Right? So, your relationship that you are creating is based off of the foreign key, and right, you still need that because that's why you're including it, right? But it's only on one side, and you look at it and say, is it a one-to-one or is it a one-to-many? Because if it's on the one-to-one, then obviously there's only one thing that matches to, but on this one, I could have multiple dependents, but they're all gonna tie back to the same employee. So the has in your example is still on here.
It's just in the table.
You are including it in the table itself as a foreign key.
Okay, cool.
Okay. Okay. So again, if we just look at the works on, right, what do we know about the primary key for this one? It's made up of 2 foreign keys. Okay. Now, it doesn't have to be, right? And what I mean by that is if you think about the concept of you taking a class and getting a grade. Right? So, a student can take multiple classes, and a class can have multiple students, so it's a many-to-many relationship. Right? And the combination of you taking a class results in a grade. Right, so that's the attribute, so that's kind of like ours here. So, right? But what's the problem with that? Here at school. If I just want to know what the last grade is, yeah, I can just do it that way. But what if I need to be able to generate a transcript for you? I have to know what semester that you took that, because you may have taken the class more than once because you withdrew from it one time or something.
Right.
Right? So, in that case, I would have the student ID as a foreign key. I'd have the course as a foreign key. I would have semester taken as a attribute as part of the composite primary key of that relation,
Right.
but it's not part of the keys on either side.
Right.
But I've had to add that to make it unique. So again, the idea would be is you should be able to work either forward or backwards from the schema layouts in your DDL and create a build ERD and come really, really close on the cardinality, because that's the only question that you would have. Is it one-to-one or one-to-many? Right? And what should tell you what the answer to that is if your company is really smart. The data dictionary should tell you that. Right? So if I'm just working backwards, I should be able to look all of this up and see how it all plays out. All right, so we said that we can have some errors with our foreign keys, right? So we have circular references, right? So we just keep spinning through, right? That's a good thing, right? Or because they refer to a table that hasn't been created yet, right? So what's our problem with this?
Too stupid.
If we have a problem with foreign keys, what happens a lot of times is your administrators turn it off, and then you have bad data out there. You turn it back on, and everything going forward is correct, but everything that happened in the point in time that you were screwing around with it, trying to fix things, there's potential errors, and now I've got problems with it. Right? So DBAs have ways to stop the enforcement to get around the problem, but the answer is no. Okay. Yeah. All right, so we talked about the fact that we have different data types, right? So again, these kind of match to your layouts that you have in the primitive data types in languages, right? But the wording may or may not be exact. Right? And as usual, we call them different things. So we have varchar or character varying, right? Or char varying, right? All mean exactly the same thing, right? Pick one, right? Right. Okay, so what we don't have in many languages, but we do have in most database management systems, is a bit variable. Okay, so what do we use bit variables for? True, false kind of things, right? Okay. Okay, we have date and time that we kind of talked about, right? So again, we have different formats that we typically use associated with that. There. Okay, we talked about domains enough times in this, right? All right, so we have the different types of constraints, right? So again, a key constraint, right? So primary key cannot be null, and it can't be duplicated because it has to be unique. Right? Okay. So our entity one is associated with that, and then the foreign key must have a value that's already present as a primary key, but it can also be null. Why would we put a null in? Because we know that there is no value in the domain at this point in time. Let's do that. So a lot of times what you'll find in the database world is we will put null into those because they don't exist yet. And then we forget to go back and actually add it when it's there, right? So again, you need to understand the data. You need to understand the way that the data is working. You need to know how it's laying out. All of that comes with your requirements and making sure that you have it correct. Okay, so we talked about the default value, right? And what does the default value mean? If I create the row or the instance of that particular thing and you don't specify a piece of data to go in there, this is a piece of data that will actually be inserted into that location. Okay. So again, a large number of companies will automatically say that they want to force you to go through and fill in all of the data items, okay, to make sure that everything is covered. You know what data that you're putting in, right? Because what do you typically not know that somebody put in a default? Right? So unless you created it, you may not know. So again, some companies will automatically say any numeric values automatically get a value of 0. Every character field automatically starts with a default value of a space. Any varchar field will automatically start with no characters in it. Right? But you can never know for sure. Okay? What is the check clause? So what's this one saying? The D number is an integer, it can't be null, and it has to be a value between 1 and 20. And what happens if it fails that check? Not going to let you add that particular row or make that particular update. Okay, as we said, we have the, right, rather than seeing it in the nice format that they had before, there's another way that you will see it written where the D number is an integer and we list it right as the primary key right in the definition, so we don't have it as a separate line. Okay. Okay. What about down here for the unique clause? Again, that's causing us to have a constraint where we are saying that even though this isn't a primary key, it is unique. Can this have a value of null?
No.
As long as it's the only one.
No. Null in the database world is treated as unknown. It has some value, you don't know what it is, and it will treat it as if it is unique. So you can have all kind of nulls and it will not violate the unique clause. Pretty nice, huh? They're so helpful.
Is that standard across?
No,
Yeah. Or no?
no,
Okay, so in some systems, that's the case, in some. Okay.
right?
That's what I thought.
But if you want it to be not null, then you should specify the same. Right. So again, right, the lesson that we're trying to say to you is that you want to be as specific as possible every time that you create something. If it needs to be unique and you want to force that, specify it. If it has to have a value, you specify it as not null, right? You are in control. All right, so when we have a foreign key, right, we have the default being we reject the update, whatever it is, so insert or update based off of having a violation. So, right, again, what does the database management system do? It looks at your request. It looks at the schema and says, this particular column has a foreign key. I need to go and look up that foreign key value in the corresponding table, in the corresponding column. If it's there, we're good. If it's not, reject the entire request. Right? Now, we can do our other options here. So if we have a violation, you can say, oh, I don't want you to stop. I want you to just set it a null, because a null is okay to put in for a foreign key, and it's going to then not have any referential integrity, because it's not going to have a value because it's null. And what's the really good news about it? It doesn't tell you that it did that. Right? Okay. Most of the time. So there are some database management systems that actually have a set of things that are called warnings. So when some action like this takes place, you get a return code that says I was able to perform it or not. And if I was able to perform it, was there anything that triggered this? So for example, in the DB2 management system, you always get a return code, and you can get multiple warning codes associated with it. So we have to check the return code to say, did I get the right return code? But I also have to say, did all of the warning messages, were they okay as well? Because I only want it to happen if it's completely correct all the way across the board. Okay? Okay, Cascade. So we talked about a little about that before, right? So what is Cascade? It says that I want to perform a set of actions. Right? So I perform a specific action, and that will carry over into behind the scenes cascading of additional actions that would take place to complete the whole thing. So for example, if I can have it so that if I delete an instance out of the primary instance, and I can have it so that it will go out and take all of the foreign key references to that and make them null. So, or I can have it so that it will actually go out and delete multiple instances of it, right? So I have cascading of deletes, cascading of updates, right? We get to specify what we want to do. Okay. Okay. So the action taken by the database management, so set null or set default, right? We can have it on both on delete, on update, right? And that cascade, as we said, is really around having this kind of relations that we are dealing with, because I am having, again, actions take place not on a single table, but typically most or multiple tables if we are doing the cascade process. Okay, right? So constraints. So again, we talked about constraints being at this point unique, not null, those kinds of things that we have. Okay. Okay. All right. So the idea here is that the constraint scenario is basically giving it a name. And so instead of you going off and just typing it in, you're giving a definition for a name. So again, in the schema or in the metadata, right, when I have constraint, I'm giving it a name, and basically what follows that is going to be the constraint. So in the example here, we have the constraint called employee super foreign key, right? And the statement that follows it is the actual constraint. So I could go out, for example, in the metadata and say, I want to see what the constraint employee super foreign key is, and it will print out that line. Right? So again, it's a way to reference what was typed in without having to necessarily go and look it up yourself. So again, we can do queries on the metadata. Right? So this is just putting in naming things. Okay. So what's happening on the constraint up there? We have a foreign key. When we say on delete, we want to set null, and on update, we want to cascade it. Okay. So what's that mean? So on delete, we want to set the references to null. So it's going to go out to the other tables and set things to null if we go off and delete this entry. Okay. What happens if we're on an update? On an update, it says go out and take the one that I changed here, change it on all the other tables. Right? So you're forcing it to do what? Maintain the integrity of the data. Right? Because that's what, obviously, the way that we want to do that. Okay. Okay. What about the next one? Instead of setting the values to null, we want to set it to a default value, right? So that means what? Do we see a value for that? We just say set default, but we don't have a value here. Where is the default set? In the original table, right? Okay, so on the original table, there's a default value that was set. In this case, you say, I want to set it to the original default, it's able to look in the metadata to see what that default value is, right? So if we look down here, right, for the manager SSN, we know that it's a character 9, it's not null, and we have a default value that's associated with that. Okay, so we're able to, again, look at the dictionary or the metadata and be able to do that. Okay. All right, so again, we come back to the check, right? So a clause at the end of a create table statement, right? So this is a check. In this case, we are able to compare the create date versus the start date of the manager, right? So again, what is the scenario for both of those? What is your expectation of the data types? They should both be dates, right? So what a lot of companies will do is at the end of the names, you specify the format of what you are looking for, if it's not a straight up number, right? So in this case, every time that we have a date, right, we actually put the word date at the end. Or if it's the scenario where we have date and time, it says date time at the end, right? So again, right, we want people to know when you are using it, what is the format of the data you are going to be receiving back. Because you may only want the date portion of it, not the time portion, right? So I would write my SQL differently if I'm retrieving just part of the data, not all of it, right? And without looking at the names like that, then I have to go to the data dictionary to find out, but if I have the naming convention like this, we're good to go. All right, so select. Select is the way that we retrieve data out of the different tables. So basically the idea is we have a select. We are saying where we want the data to come from, right? Okay, and what are the conditions that we are doing it, right? Okay, so we are able to look at it and, right, basically retrieve not only a single value, we can retrieve no value, or we can retrieve a set of values. Okay, because obviously it will match in one or more ways. Okay. So our scenario is we want to have this basic form where we are selecting, and we list all of the column names of what we want to retrieve. And we can always use the really cool wildcard of an asterisk, and it will get me all of them. Okay. From, where is the table or set of tables that we want to retrieve things from? So we have the idea that we can go through and we can do what we call joining tables. So based off of the tables that I'm looking for, I can retrieve data from multiple relations or multiple tables with one request, but that means that I have to tie them together in some way. Okay, and the where clause is what is the conditions that we are going to apply to tables. So attribute list is what are all the attributes we want. The table list is what are the relations that we want to process our query against. And then the condition is the scenario of what is the expression that is going to apply. Right? So you have to have a minimum of a select from. So if I say select asterisk from employee, I'm going to get all of the columns from the employee table returned, because I didn't have any condition associated with those. Okay, in the Boolean expression, we have the regular logical operators of equal, not equal, and, ors, all those kinds of things that we can use. Okay? So you guys are used to having, for example, in C++, you have the exclamation point equals being a not equals, right? Okay, well, we don't have that here. We have the greater than, less than combination saying that it's not equal, right? Okay, and you guys that are used to in C++ putting the two equal signs together, well, now it's back to 1. Right? So it's the same kind of thing. Okay. Okay. Okay, so we have also the idea of what we call projection attributes. So we have ways that we can say, this is the data that I want to retrieve, and I can say this is where I want it to go. So if I embed this SQL inside a programming language, so for example C++, I can say, I want this piece of data returned from this particular column, and I want it to be loaded into this particular variable in C++. So I can get down to that level of detail. Okay, and in our selection, right, we have to obviously have a true for anything to be returned, right? And we'll see some examples of this later on. But the idea is that I can have return of no rows. Okay? So again, every single database management system is going to have a return code that says this did not return something. Okay? And again, it will vary by database management system what the return code is. Okay. So in our couple of examples here, right, we have, we're selecting the birth date and the address from the employee, where we're looking for John B. Smith. Okay. So what's it going to do for this one? It's going to look for John B. Smith in the employee table, and is going to return the birthday and the address. Okay, but what do we know about first name, middle initial, and last name? Are those part of the primary key? No. So what's it going to do? Potentially scan all of the employees, checking every single instance to see if it's equal. Well, it's not bad if you have 1,000 employees, but what happens if you're Kendra's Bits and Bytes and has like 10,000 employees or 10 million employees, right? Okay, it can take a long time to do. So this is going to potentially do what we call a table scan. So a table scan is, I'm not using a direct key, so therefore I'm going to scan the entire table to find the result that I am looking for, or not find it. Okay, and what about the next one? I want to return the first name, last name, and the address, and I want to look at both the employee and the department table. So I'm looking at two different tables, and I want to return it where the department name is research and the department number is equal to the department number. So we had two department numbers, right? So one of these is on the employee table and one is on the department table. So I'm looking to see which ones match. And out of that matching set, I only want to select the ones that have research as part of the name. Okay, so this is actually easy to do because the names are different. Okay, because we have D number where number is spelled out, and we have D number where its number is NO. Okay. Now, we can have them so they have the exact same name. There's no restriction on that. So if we have to do that, you specify before this using a dot operator which table that you are actually looking to use. So for example, if it was D followed by the word number in both of them, you would have employee.d number equal to department.d number. Okay, to make sure that they're equal. So with that, have a great night.